Hi everyone. Today we're going to be reviewing linear equations. Before we jump into systems of linear equations, I wanted to do a quick review of each of the forms of linear equations. This review is going to cover slope as a rate of change, slope-intercept form, point-slope form, standard form, and horizontal and vertical lines. Let's begin with slope as a rate of change. Slope is often taught as a formula in both math and science, rather than as an important concept known as the rate of change. Rate of change is used in business in discussing climate change, engineering, in the stock market, and most recently in COVID 19, date just to name a few. Here's an example from Forbes.com. The World Health Organization warns of alarming coronavirus growth rate in Europe. So this is talking about a rate of change and how is it changing? It's growing. We also talk about a rate of change as decreasing or decaying. In first semester, you learned how to solve linear equations. An example of one of these equations is 2x plus 8 equals 14. We would solve this by first subtracting 8 from both sides of the equation, then dividing by 2. You also learned how to graph linear equations. The graph of a linear equation is a line. We look at graphing linear equations when considering the slope because slope is the rate of change of a line. So when we're looking at the graph of a line, we analyze the slope. Is it positive? Is it negative? Is it undefined or is it zero? That slope tells us how the function is changing. We can represent slope in many ways. We use the letter m to represent slope. Sometimes we'll refer to it as rise over run, vertical change over horizontal change, delta y over delta x, and that delta is just a capital Greek letter, means change in. Or we can represent it using the slope formula, y2 minus y1 over x2 minus x1. There are four ways that we can find the slope of a line. We can find it graphically, algebraically, numerically, and verbally. So let's start by finding the slope graphically. Over here, we've got this graph which shows the height of a rock climber over time. So we can see that at 0 seconds, the height of the rock climber is 26 meters. After 8 seconds, the height of the rock climber is 0. So the rock climber has reached the ground. So to find the slope of this line pictured above, we can look at the graph. So as we read the graph from left to right, so from 0 seconds to 8 seconds, I can see that the graph moves down and to the right. So it goes down 26 and it goes to the right 8, a positive 8. So if we know that the slope is rise over run or vertical change over horizontal change, delta y over delta x, well, the vertical change is down 26 or negative 26, and the horizontal change is positive 8. So our delta y over delta x, our slope, is equal to negative 26 eighths, or reducing that fraction, we get negative 13 fourths. And that is our slope. So what does that mean in terms of this application? That tells us that the rock climber is descending 13 meters every 4 seconds. The rock climber is descending 13 meters every 4 seconds. So again, slope is change in y over change in x. So how is the height changing per unit time? Well, it's changing 13 meters. We're going down 13 meters for every 4 seconds. That's our rate of change. On to the next page, let's go ahead and find the slope of each of these line segments. So on the left, I'm looking at segment CD. So to find the slope graphically of segment CD, I'm going to start from the left-hand point and move to the right-hand point. So I see that C. We're going to go down 1, 2, 3, 4, 5. So we're going down 5. And we're going to the right 1, 2, 3, 4. So we're going to the right 4. Because we're going down, this is the negative y direction, and we're going to the right is the positive x direction. So our slope, change in y over change in x, is equal to negative 5 over positive 4, or negative 5 fourths. For segment EF, I see segment E over here, and point E over here, and point F over here. Our vertical change, well, in order to get from E to F, as we move from left to right, we don't have to move up or down at all. So our change in Y is equal to 0. We're not moving up or down at all. However, our change in X, we're going to the right, 1, 2, 3. So our change in X, our horizontal change, we're moving to the right 3, which is the positive X direction. So we have a positive 3. Well, 0 over 3 simplifies to just 0. So our slope for segment EF is 0. Very important, the slope of a line is read graphically from left to right. So as we're looking at these segments, these lines, the slope between the 2 points, we're going to read it from the left point to the right point. And depending on whether or not the graph is going upward, downward, not going up or down at all, or it's completely vertical, that's going to tell us if the slope is positive, negative, 0, or undefined, respectively. Now let's find the slope numerically. So given these tables of values, how can we find the slope? Again, we're going to use that change in Y over change in X. So now let's look at number 4. So how is the Y changing? Well, as I go down the table, how is the Y changing? Well, from 11 to 17, we're adding 6. From 17 to 23, we're adding 6. From 23 to 29, we add 6. And 29 to 35, we add 6. So this tells us that our delta Y, or a change in Y, is positive 6. Our change in X, as we move from one X to the next, so as we go down the table, to go from 2 to 4, we're adding 2. From 4 to 6, we add 2. 6 to 8, we add 2. And 8 to 10, we add 2. So our change in X is positive 2. Our change in Y over change in X, 6 over 2, reduces to a positive 3 over 1, or just 3. For number 5, our change in Y, every time we are, instead of adding a number now, to go from 4 to 2, we're subtracting 2. 2 to 0, we subtract 2. And we find that this trend continues. So our delta Y, our change in Y, is negative 2. Our delta X, our change in X. So from negative 3 to 0, and from 0 to 3, from 3 to 6, and from 6 to 9, we're adding 3 each time. So our change in X is plus 3, or positive 3. So our slope is a negative 2 over positive 3, or negative 2/3. Next up, let's find the slope algebraically. So whenever we're given 2 points on a line, we can find the slope between those lines using the slope formula, y2 minus y1 over x2 minus x1. So let's find the slope for number 6 between the points negative 2, 2 and 2, 7. First thing I like to do is just label the points x1, y1, and x2, y2. These are xy coordinates on the coordinate plane. So to find the slope, I'm going to set up my formula. So y2 minus y1 over x2 minus x1. Well, y2, we're plugging that in, is 7 minus y1 is 2. X2 is 2 minus x1 is negative 2. So be very careful here. We're subtracting a negative. In the numerator, 7 minus 2 is positive 5. In the denominator, 2 minus negative 2 is a positive 4. Remember, subtracting a negative is the same as adding a positive. Always check and see if you can reduce your fraction or simplify your slope. Here we have 5/4. That cannot be reduced, so that's our final answer. Number 7. To find the slope between these points, I'm going to first label my points x1, y1, x2, y2, and set up our formula. M equals y2 minus y1 over x2 minus x1. So our y2 is 4 minus y1 is 5 over x2, which is negative 6, minus x1, which is also negative 6. So we're subtracting negative 6. In the numerator, 4 minus 5 is negative 1. In the denominator, negative 6 minus negative 6. Well, subtracting a negative is the same as adding a positive. So negative 6 plus positive 6 is equal to 0. Now here I see a big red flag here. We've got -1 over 0, or -1 divided by 0. There's only one number in math that we cannot divide by, and it's 0. If you try to plug in -1 divided by 0 in your calculator, you're going to get a divide by 0 error. And the reason why is we can never divide by 0. Okay? So, because our slope is dividing by 0, this line has undefined slope. This is a vertical line, and we'll see what that looks like a little later on when we talk about horizontal and vertical lines. When just looking at the slope is undefined. And last, let's go ahead and find the slope verbally on the next page. So when given the relationship between two quantities, an x and a y, the slope is determined as the change in the dependent variable over the change in the independent variable. So if I have this example here, a car accelerates for 5 seconds, increasing its speed from 10 miles per hour to 30 miles per hour. We first have to consider what is the independent variable and what is the dependent variable. Does the time depend on the speed, or does the speed depend on the time? In this scenario, the speed is going to depend on the time. So the time is independent and the speed is the dependent variable. So again, we have change in y over change in x. So our change in our dependent variable is our change in speed, which is 30 minus 10. So this is the final speed, and this is the starting speed. Our independent variable is our time. So we're doing final time minus the starting time. Well, it takes 5 seconds to accelerate. So the final time is 5 seconds, and the starting time, we start time at 0. So our starting time is 0. Simplifying this, we have 30 minus 10 is 20 over 5 minus 0 is 5. And we can reduce further. 20 divided by 5 is 4. Let's go ahead and include units in our answer. So this is changing of 4 miles per hour per second. So that is our units of our y over the units of our x. And that's just saying that the car is accelerating every second an additional 4 miles per hour. Okay, that's it for slope. Let's move on to 2-1, which is slope-intercept form. You may recall that slope-intercept form is the form y equals mx plus b. It's one of the forms that we looked at in the previous chapter, where m is the slope and b is the y-intercept. Remember, m tells you how steep the line is, and the y-intercept b is where the line crosses the y-axis. It's where it crosses the y-axis. So to graph a line in slope-intercept form, we first have to look at the equation and plot the y-intercept. So in this first equation, in number 9, we have y equals 1/4 x plus 1. Our slope is that number in front of x. So in this case, our slope is 1/4. Our y-intercept is that constant term tacked on at the end. So our y-intercept is 1. I always like to write our y-intercept as an ordered pair. So the y-intercept as an ordered pair is 0, 1. So step 1 is to identify and plot the y-intercept. So we'll go ahead and plot the point 0, 1. Step 2 is to use the slope to plot more points. So the slope, remember, is change in y over change in x. We're going to go up 1 and to the right 4, giving us our second point right here. We're going to keep doing that until we get as far as we can on the grid. I like to fill the grid as much as I can. And so we have these 3 points right here. We could also go in the other direction and go left 4 and down 1, or down 1, left 4, and continue plotting along the same line. And last, step 3 is draw a line through the points, and don't forget to draw your arrowheads. Let's see how straight I can draw this. If you have a straight edge like a ruler or an ID, calculator case, anything that you can use to draw a straight edge on your paper, or if you're using Kami, you can use the straight line tool to draw your line. Don't forget those arrowheads. This line extends infinitely in both directions. All right, number 10. Y equals -3x plus 7. Here our slope is -3, and our y-intercept is +7. So as an ordered pair, we have the y-intercept 0, 7. So let's go ahead and plot that point and use our slope, -3. which I always like to represent the slope as a fraction, change in y over change in x. So negative 3 can be rewritten as negative 3 over 1. And so that tells us we're going to go from our first point down 3 and to the right 1. And I'm just going to fill the rest of the grid until I can't anymore. Down 3, right 1, down 3, right 1. You can also go up 3 and left 1 to fill in the other side of the y-axis. Go ahead and draw your line as straight as you can. Use that straight edge. Draw in those arrowheads, and we've got the line. Y equals negative 3x plus 7. Let's continue on. Oh, we got to identify our slope and y-intercept. So our slope in number 9 is 1/4. And our y-intercept is 0, 1. I'm going to write it as an ordered pair. And number 10, our slope is negative 3, and our y-intercept is 0, 7. Okay, let's continue. Number 11, write the equation of the line in slope-intercept form that's graphed below. So we're going to work backwards. Now we've got the graph. I'm going to identify the y-intercept first. Remember, the y-intercept is where the line crosses the y-axis. Here, the y-intercept is 0, positive 2. For the slope, we got to find other points that cross the grid lines very nicely. So I see one right here, maybe another right here, another right here. So this tells me, so we can find the slope graphically, I'm going to go down 2 and to the right 3. So our slope must be negative 2 over positive 3, or negative 2/3. Using these two pieces of information, we're going to write this in slope-intercept form, which as a reminder is y equals mx plus b. So our equation is y equals negative 2/3 x plus 2. All right, on to 2, which is point-slope form. So point-slope form, like slope-intercept form, uses the slope and the y-intercept. Point-slope form uses a point and the slope. This is the form y minus y1 is equal to m times the quantity x minus x1, where m is the slope, as we've seen before, and x1, y1 is a point on the line. It's not necessarily the y-intercept, though it could be. It's just any point on the line. So let's go ahead and write the equation of the line. That should say write the equation of the line in point slope form, whose slope is 5 and passes through the point negative 2, 6. So again, this is y minus y1 is equal to m times the quantity x minus x1. So our slope is 5, and our point, x1, y1, is negative 2, 6. So plugging this into point slope form, we get y minus 6 is equal to 5 times x minus x1. x1 is negative 2. And notice what happens here. We have x minus negative 2. We could simplify that further. And remember, subtracting a negative is the same as adding a positive. We could simplify that to just x plus 2, or x plus positive 2. So here's our equation in point slope form. To graph a line in point slope form, similar process. We're going to identify and plot the point from the equation. We're going to use the slope to plot more points, and then draw a line connecting all of the points. So number 13. Let's start with slope and points. So from this equation, slope is that number in front of the grouping. So in this case, we have negative 1/4. The point, remember, is x1, y1. Well, I know that the formula is y minus y1, and I know it's x minus x1. So in order to find x1, I have to consider what number would I subtract from x in order to get x plus 1. And the number that I would subtract from x to get plus 1 is negative 1. Remember, subtracting a negative is the same as adding a positive. So that tells me that my x1 is negative 1. For y1, well, what number do I have to subtract from y to get y minus 3? The answer is 3. So our y1 is positive 3. From here, step 3, we can plot our points. Or step 2 and 3, we can plot our points and graph the line. So starting with negative 1, 3, we have this point right here. And then using our slope, negative 1/4, I'm going to go down 1 and to the right 4 to get my additional points. You can also go from that point and go up 1 and to the left 4 to get additional points there. Connect your dots, and you got a line. Draw those arrowheads, and there we go. Number 14. So to find the slope, again, it's that number in front of the grouping. So we have just positive 3. As a fraction, I always like to write my slope as a fraction. That's 3 over 1. You can put any integer over 1. It's not going to change its value. You can put anything over 1. It's not going to change its value. For the point, x1, y1, well, I noticed that x1, we're subtracting 6, so then our x1 must be 6. But our y1, we're not subtracting anything from y. It's just y. We could also rewrite this as y minus 0, therefore telling us that our y1 is 0. So our point is 6, 0. So we'll go ahead and plot that point, and then using our slope to find our other points, from there we're going to go up 3 into the right 1, up 3 right 1, and so on. Can also go down 3 left 1, and we've got this line here. All right. Moving on. Let's write the equation of the line in point slope form that passes through 8, -1, and 3, 9. So in order to find the equation here, we first have to find the slope. We've got 2 points here. We only need 1, but we've got 2. We don't have the slope. Remember, in order to find the slope, we can use our slope formula, m equals y2 minus y1 over x2 minus x1. So let's go ahead and label our points x1, y1, and x2, y2. So then in our formula, we have y2 is 9 minus y1 is -1 over x2, which is 3, minus x1, which is 8. 9 minus -1 is a positive 10, and 3 minus 8 is -5. Reducing this fraction, 10 divided by -5 is -2. So there's our slope. Actually, I don't want to circle that yet because that's not our answer. But our slope is -2. There we go. So to write the equation, it doesn't matter which point you use. You can choose either point to plug it into your formula. I'm going to choose the first point, x1, y1. So remember, our point slope form is y minus y1 equals m times the quantity x minus x1. So we have y minus -1 equals our slope, -2, times x minus x1, which is 8. And we can simplify y plus 1 equals -2 times the quantity x minus 8. And that's our final answer. Yes, you could have also plugged in 3, 9 and gotten the equation y minus 9 equals -2 times x minus 3. All right, last form is standard form, which is ax plus by equals c, where a, b, and c are integers, not fractions, not decimals. So one of the advantages of writing linear equations in standard form is that it's pretty easy to find both the x and y intercepts. Remember, intercepts are where the graph of the line crosses the axis. So when we talk about y-intercept, that's where the graph crosses the y-axis. And likewise, the x-intercept is where the graph crosses the x-axis. Algebraically, the x-intercept is where y equals 0, and the y-intercept is where x equals 0. So let's go ahead and find intercepts and graph linear equations in standard form on the next page. Number 16, let's find the x and y intercepts and graph the line. So remember, to find the x-intercept, this is where y is equal to 0 in the equation. And I'll even go ahead and write for the y-intercept, that's where x is equal to 0. So in order to find intercepts, I'm just going to rewrite the equation. 3x minus 9y is equal to 36. To find the x-intercept, we're going to plug in 0 for y. So we have 3x minus 9 times 0 is equal to 36. And then solve for x. So 3x minus, 9 times 0 is 0. So we have 3x minus 0 equals 36. Subtracting 0 doesn't change anything, so we can just drop that. We get 3x equals 36. And last step, to get x by itself, I'm going to divide both sides by 3, and I get x is equal to 12. As an ordered pair, the x-intercept is 12, 0. X comma y, x equals 12, y equals 0. So we can plot that point. Ooh, unfortunately, it's a little off the graph, so I'm going to estimate it's right about there. To find the y-intercept, Again, we'll start off just by writing out the equation. We're going to plug in 0 in for x. So we have 3 times 0 minus 9 times y is equal to 36. Well, 3 times 0, that's just 0. So we have 0 minus 9y is equal to 36. 0 minus 9y is just negative 9y, so we can drop that 0. And last step, divide both sides by negative 9, and we get y is equal to negative 4. So as an ordered pair, x comma y, we have 0, negative 4, which we can also go ahead and plot. So now we've got 2 points. That's all you need to graph this line. So I'm going to go ahead and sketch this line as best I can. Hopefully you've got a straight edge as well, and so your graph is pretty straight. Use that straight edge. Draw those arrowheads, and we've got a line. Number 17. Let's find the x and y intercepts. So remember, the x-intercept is where y equals 0. So we'll find that first. Rewriting the equation, negative x plus 8y equals 16. Plugging in 0 for y, we get negative x plus 8 times 0 is equal to 16, or just negative x plus 0 equals 16. Negative x is equal to 16, divide by negative 1, and we get x is equal to negative 16. So our x-intercept, again, is off the grid. We can approximate it's way out there, negative 16, 0. Now the y-intercept is where x is equal to 0. So we'll plug in 0 for x. So again, I'm just rewriting the equation. Negative x plus 8y equals 16. Plug in 0 for x using parentheses. And we get negative 0 plus 8y equals 16. Well, negative 0 or negative 1 times 0 is just 0. Plus 8y equals 16. Adding 0 doesn't change anything, so we get 8y equals 16. And last, dividing by 8 gives us y equals 2. So as an ordered pair, our y-intercept is 0, 2. All right, let's go ahead and sketch this graph. This one's kind of tricky. It's pretty flat, but you can see it does have a positive slope. From left to right, it's rising. It's going up. So I wanted to show you a trick for finding intercepts as well. So let's again find the x-intercept. So that's where y equals 0. One thing you may have noticed, a pattern that you've noticed maybe with standard form and finding intercepts, is that whatever term that we're plugging in 0 for, that whole term cancels out. So if we're plugging in 0 for y to find the x-intercept, that whole y term just zeroes out, it cancels out, and you're just left with the negative 8x, the x term. So what we can do is, I like to use my finger and just cover it up on the worksheet, or you can just cancel out that whole term. And we're just left with negative 8x equals negative 24. And you can see how this makes the problem much simpler. It's down to one more step. Dividing both sides by negative 8, we get x is equal to positive 3. So that's a quick trick that you can use when finding intercepts in standard form. To find the y-intercept, that's where x is equal to 0. So negative 8x plus 6y is equal to negative 24. Again, that whole x term is going to cancel out, and we're just left with 6y equals negative 24. Dividing both sides by 6, we get y is equal to negative 4. I like to use the trick. Works really well in standard form, and it helps us find those intercepts pretty easily. All right, so graphing that line. Draw those arrowheads, and we've got the line here. All right. So now let's given the graph, let's see if we can find the equation. So I know that the x-intercept is at 4, 0. And I know that the y-intercept is at negative 0, negative 9. So I need to know, well, what equation, ax plus by equals c, what equation will give us intercepts of 4 and negative 9? Well, I know that 4 times 9 is 36, or 4 times negative 9 is negative 36. So let's just plug in a few values here. If I know that the x-intercept is 4 and the y-intercept is negative 9, What if I did 9x minus 4y is equal to 36? Let's just do a quick check and see. Well, our x-intercept would be canceling out that y term, so we'd have the equation 9x equals 36. And indeed, dividing both sides by 9 gives us our x-intercept of 4. For our y-intercept, plugging in 0 for x, we get the equation negative 4y equals 36, and indeed, dividing by negative 4 gives us our y-intercept of negative 9. So I always like to do that quick check just to make sure that we've set up our equation properly. So our equation is 9x minus 4y is equal to 36. The last thing that we're going to talk about today, I know this has been a long one, is horizontal and vertical lines. This one's pretty quick. So if either of the a or b values in standard form are 0, then notice that that whole term cancels and you're just left with an equation similar to these over here, x equals 4 or y equals negative 9, when simplified anyway. So let's take a look at this first example, 0x plus 2y equals 8. If we simplify this equation, cancel out that x term, we get 2y equals 8 or y equals 4, dividing both sides by 2. So the equation is y equals 4. We can see the graph over here. We've got y equals 4, which is completely horizontal. The slope of this line is rise over run, change in y over change in x. Well, this isn't changing vertically at all. So the change in y is 0. Change in x is anything, depending on the points. If we choose this point and this point, we're changing 1, 2, 3 to the right. We can choose any 2 points. The slope is always going to be 0. And that's true for all horizontal lines. The slope of all horizontal lines is 0. Now, what does the graph look like when b equals 0, when the y term cancels out? Well, we get this equation here. For this example, 3x equals 6. Dividing both sides by 3, we get x is equal to 2. We get this line here. Well, change in y over change in x. Well, change in y, if we choose any 2 points on this line, change in y here, we could go like up 3. And then change in x, we're not moving right or left at all. There's no horizontal change. That's 0. Now remember earlier when we had something over 0, we can't divide by 0. The slope of this line is undefined. And that's true for all vertical lines. The slope of vertical lines are undefined. So in summary, horizontal lines are always in the form y equals k, where k is just a constant, a number, and have a 0 slope. Vertical lines are always in the form x equals h. Again, h is a constant, it's just a number, and have an undefined slope. All right, so let's wrap everything up. A quick summary. There are 4 types of slope. We read slope from left to right on the graph. I like to envision like a car on there, right, on the line. If it's going uphill, then it's a positive slope. If it's going downhill, it's a negative slope. If it's not going up or downhill, it's just completely flat. That's a 0 slope. And then an undefined slope, you can think of this as like an infinite slope or infinitely steep. This car would not be able to ride on this, so it would be an undefined slope. For slope-intercept form, as a reminder, is y equals mx plus b, where m is the slope and b is the y-intercept. We can find the slope graphically by looking at the vertical change over the horizontal change, and the y-intercept by looking at where the graph crosses the y-axis. In 2.2, we looked at point-slope form. So this uses a point and the slope. This is the form y minus y1 equals m times the quantity x minus x1. And last, we talked about standard form, which is the form ax plus by equals c, where a, b, and c are integers. Remember, not fractions, not decimals. They have to be integers. This is really helpful for finding intercepts, both the x and y intercept. All right. So that's been our quick review, or maybe not so quick review, on linear equations. I hope this was really helpful. We're going to get some practice on this, and then we're going to dive right into systems of linear equations. I hope this was helpful. We'll see you tomorrow. Bye.